faster than the fabric of space-time can keep up with it, and it'll just rip. And I'm terrified by this.
In the vast ocean of stars that paint our night sky, there are a few that command attention, not just because of their brightness, but because of the mysteries they hold. Among them, Betelgeuse stands as one of the most enigmatic and closely observed stars in our galaxy. Located around 642 light-years away in the constellation of Orion, Betelgeuse is a red supergiant, a celestial titan so massive that if it replaced our Sun, its outer layers would stretch all the way past Jupiter. And recently, it has done something that has left astronomers around the world stunned. A sudden, massive increase in brightness. The James Webb Space Telescope, one of the most advanced instruments ever created, has just detected a 250% surge in the brightness of Betelgeuse, igniting a flurry of scientific curiosity, speculation, and even concern. This isn't the first time Betelgeuse has captured headlines. Back in late 2019 and early 2020, it made waves when it mysteriously dimmed, losing a significant portion of its brightness over just a few weeks. That dramatic fading event led many to believe that the star might be on the brink of going supernova. However, the cause was later traced to a combination of dust clouds and surface cooling, temporarily obscuring the star's light. But now the situation seems reversed. Instead of fading, Betelgeuse is blazing even brighter than before. And what's even more astonishing is the scale of this increase. A 250% boost in brightness for a star of this magnitude is not only rare, it's almost unheard of. So, what exactly does this mean? Could it be a sign that the red supergiant is finally nearing the explosive end of its life? Or is something else entirely at play? Perhaps a phenomenon we've never observed before? The answers may lie in the detailed data collected by the James Webb Space Telescope, which is uniquely equipped to peer into the heart of Betelgeuse like never before. With its unprecedented sensitivity to infrared light and its ability to see through cosmic dust, the JWST has opened up a new window into the behaviors of distant stars, and Betelgeuse is now in the spotlight once again. To understand the significance of this event, we need to look at what Betelgeuse is and why scientists have been so obsessed with it for decades. As a red supergiant nearing the end of its stellar life, Betelgeuse is in a very unstable phase. It's burning through the last stages of nuclear fuel in its core, producing elements like carbon, neon, and eventually iron. Once it begins fusing iron, the process no longer releases energy, leading to an unstoppable gravitational collapse. That collapse will then result in one of the most dramatic events in the universe, a core collapse supernova. And when that happens, Betelgeuse will briefly shine as brightly as an entire galaxy, visible even in the daytime sky from Earth. This possibility has long made Betelgeuse a prime candidate for study. However, predicting exactly when a supernova will occur is incredibly difficult. Even with all our modern tools, we still don't fully understand the complex internal dynamics of massive stars. But anomalies in brightness, like the recent surge detected by JWST, could provide critical clues. According to the data, Betelgeuse began to brighten rapidly over the course of just a few weeks, increasing in luminosity by more than 2.5 times its previous output. This isn't a subtle shift. It's a dramatic change that suggests something major is happening beneath the surface. The James Webb Telescope's ability to capture this moment in such fine detail is a testament to how far astronomy has come. Its instruments can detect tiny fluctuations in light and temperature, map out surface features on distant stars, and even analyze the chemical compositions of stellar atmospheres. For Betelgeuse, this means that scientists can now observe features like convection currents, shock waves, and gas outflows with unmatched precision. Early analysis of the new data points to large-scale changes in Betelgeuse's outer envelope, regions where energy and matter are violently moving and possibly escaping into space. One theory gaining traction is that Betelgeuse may have undergone a massive convective event. In simple terms, convection is the process of heat and material rising and falling inside a star, much like boiling water. In stars like Betelgeuse, these convection cells can be enormous, larger than the entire orbit of Earth. If one of these cells brought a huge amount of hotter material from deeper layers up to the surface, it could result in a noticeable spike in brightness. This would explain the sudden increase in light without necessarily indicating an imminent supernova. However, there are other more speculative possibilities that scientists are also considering. Some researchers are entertaining the idea that Betelgeuse could be undergoing a pre-supernova outburst, a final gasp before the star collapses. Such outbursts have been observed in other stars that went supernova shortly after, like SN 209IP and SN 2010MC. In these cases, the stars experienced rapid changes in brightness and expelled huge amounts of mass in the months leading up to their explosions. If Betelgeuse is following a similar path, we could be witnessing the prelude to a celestial spectacle the likes of which humanity hasn't seen in centuries. But let's not get ahead of ourselves. While the brightness spike is dramatic, it's important to remember that Betelgeuse is an inherently variable star. It pulsates on regular cycles with changes in brightness occurring over periods of months or years. These pulsations are tied to the star's internal structure and can vary in strength over time. The 250% increase could in theory be a particularly strong peak in one of these cycles, although that would still make it the most powerful one recorded in recent memory. The key difference here is that now we have the James Webb Space Telescope watching every move with unparalleled clarity, offering data that could finally distinguish between normal variability and something truly extraordinary. The implications of this event stretch far beyond Betelgeuse itself. If it does go supernova within our lifetimes, it would be the closest such explosion in modern history. Although 642 light-years might sound distant, it's astronomically close on a galactic scale. The light from the supernova would be so bright that it could cast shadows at night and remain visible for weeks or even months. Fortunately, the event wouldn't pose any direct threat to life on Earth. The radiation would be harmless at that distance, but the scientific opportunity would be monumental. Astronomers would have front-row seats to study a quark collapse supernova in exquisite detail, potentially solving long-standing mysteries about how heavy elements are formed, how neutron stars or black holes are born, and how shock waves shape the evolution of galaxies. And there's more. The surge in brightness could also affect the surrounding interstellar environment. Betelgeuse is already shedding material in vast plumes and arcs of gas and dust, creating a complex circumstellar envelope. If the star is entering a more active phase, this material could interact with surrounding clouds, triggering new star formation or altering the dynamics of the local region. In fact, some infrared images captured by JWST suggest that Betelgeuse may be shaping its environment in real time, carving out cavities in the surrounding medium and sending shock waves into space. That leads to a compelling idea. What if we are not just witnessing a brightening star, but an entire region of space in transformation? Betelgeuse might be acting as a cosmic sculptor, using its stellar winds and eruptions to shape the future of the Orion constellation. The increase in brightness could be a sign of this transformation accelerating with more energy and mass being pushed into the cosmos. What makes this moment even more profound is the timing. Humanity is now equipped with the tools to observe stellar phenomena at a level never before possible. A century ago, astronomers could only guess what was happening inside stars based on their flickering points of light in the sky. Today we have instruments that can peer through dust, analyze spectra, and capture images in multiple wavelengths. With the James Webb Space Telescope in operation, every flicker and pulse from Betelgeuse can be scrutinized in real time. This means that if the star is entering a pre-up supernova phase, scientists might actually be able to catch the final moments of a dying supergiant, data that could reshape our entire understanding of stellar evolution. But even if Betelgeuse doesn't explode in our lifetime, what we're witnessing is still of enormous scientific value. The sudden 250% increase in brightness is not just a curiosity. It's a clue about the internal mechanisms that drive massive stars, about the turbulent convection layers that churn within them, and about the ways in which they lose mass before reaching their final fate. Every piece of data from this event will help refine the models that predict how stars live and die. It's like having a real-world laboratory for studying the most extreme physics the universe has to offer. The possibility of a supernova still looms in the background of every conversation about Betelgeuse. And that's not just hype. It's based on solid astrophysical theory. When stars like Betelgeuse run out of fusible material in their cores, they collapse under their own gravity in a matter of seconds. The outer layers rebound off the collapsing core, creating a powerful explosion that hurls elements into space. These elements, carbon, oxygen, calcium, iron, are the building blocks of planets, oceans, and even life itself. In fact, every atom of iron in your blood was once forged in the core of a dying star. So if Betelgeuse does go supernova, it will be both an end and a beginning. The death of a star and the seeding of future worlds. And yet, despite all this grandeur, Betelgeuse remains a mystery. The more we learn, the more questions arise. What causes its massive surface activity? Why does it sometimes expel clouds of dust and gas large enough to dim its entire output? How exactly will its final moments unfold? And could there be factors at play that we haven't even imagined yet? That's where the James Webb Telescope shines. With its advanced instruments, it's not only providing clearer images, but also uncovering chemical signatures in the star's atmosphere. It's showing us the fingerprints of molecules and elements being produced in real time. It's turning speculation into measurable science. For example, recent observations by Webb show unusual movements of silicon monoxide and aluminum oxide, molecules that suggest rapid heating and cooling and possibly even shock waves traveling through the outer layers of the star. These could be linked to the convective surges theorized earlier, or they could point to more exotic processes like magnetic field disruptions or rotational instabilities. Whatever the cause, the JWST has given us the clearest evidence yet that Betelgeuse is in a state of flux. In response, observatories all over the world have turned their eyes to the Orion constellation. Radio telescopes, X-ray observatories, and even ground-based optical arrays are working in tandem to build a full-spectrum view of what's happening. Citizen scientists and amateur astronomers are also contributing, documenting any visible changes from their own backyard telescopes. It's become a global collaboration, one that reflects our deep fascination with the cosmos and the sense of wonder it inspires. And as we watch, we're reminded of just how dynamic and unpredictable the universe can be. Stars, once thought to be eternal and unchanging, are anything but. They are living systems pulsing with energy capable of both immense destruction and cosmic creation. Betelgeuse, in particular, feels like a star with a story to tell. It has behaved unpredictably in the past, and this latest brightness increase is yet another twist in an ongoing cosmic drama. Perhaps we are watching the final act, or perhaps it's just a dramatic chapter in a longer narrative. Regardless, the lessons we gain from observing Betelgeuse will ripple across multiple fields of science. Astrophysics, cosmology, stellar dynamics all stand to benefit from the data pouring in. It may help us better understand how similar red supergiants evolve, how long they remain stable, and what early warning signs precede their collapse. That knowledge could one day allow us to predict supernovae with much greater accuracy, helping us prepare for similar events in other parts of our galaxy. There's also an emotional and philosophical dimension to all of this. We're witnessing change on a cosmic scale, massive, violent, yet natural. It's a humbling reminder that the universe is in constant motion, that creation and destruction are part of a larger cycle. Watching Betelgeuse is like standing at the edge of time itself, catching a glimpse of a future explosion that may light up our skies, echoing across the centuries. It connects us not just to the cosmos, but to the countless generations who have looked up at the same star and wondered what secrets it holds. The coming months will be critical. Scientists will continue to monitor Betelgeuse for any further changes. be it a dip in brightness, a burst of radiation, or the telltale neutrino emissions that might signal the beginning of a collapse. And with every observation, the picture becomes clearer. The James Webb Space Telescope has already revolutionized our understanding of distant galaxies and exoplanets. And now it's bringing that same transformative power to the study of our local stellar neighborhood. In doing so, it's not just revealing the secrets of Betelgeuse. It's changing how we understand stars, life, and the very fabric of the universe. Whether Betelgeuse explodes tomorrow or thousands of years from now, this 250% increase in brightness is a moment to remember. It's a reminder that even the oldest, most familiar objects in the sky can surprise us. That science is an ever-evolving journey of discovery. And that somewhere out there, a red supergiant is blazing with an intensity we've never seen before, beckoning us to keep watching, keep wondering, and keep reaching for the stars.